Hey guys, see in yesterday's live session of YouTube, there was some problem with the application. Some technical error was there, so that's why we couldn't complete nodal analysis yesterday. And at the same time, nodal analysis has to be completed at a stage. Okay, means some normal we have to take, and immediately we can go to super node, and immediately super node limitations we should know. Okay, but yesterday I couldn't complete, so that's why means very basics whatever we discussed yesterday from starting 10-15 minutes I'm not going to discuss again, but in order to complete this at a stage we should go. Okay, now before starting anything, let me start about myself. I'm KN Rao. I got more than 20 years of teaching experience, and I too got BRC kind of many jobs and all. Anyway, I should have got at least more than 1 lakh students because 20 years. And the subjects, as of now, in electrical machines, transformers, I started in plus. And basic concepts of rotating machines, I started in special platform. Special, that is free for all. And power systems, I will include soon. Okay. Next thing is KNR 10. Now, in order to activate your free initiatives also, free initiatives by Unacademy also, if you use my code, you can claim that. And next thing is you can get 10% discount. Okay, in the paid subscription. Okay. Now next thing is in Unacademy there are two kinds of platforms: plus platform, iconic platform, apart from YouTube, and apart from special classes. If you want to pay, and in plus live classes will be there, crash courses will be there, weekly tests will be there, doubt solving will be there, English and Hindi batches will be there, ranking book batch will be there. Once you take one Unacademy subscription, independent of branch, independent of batch, in everything is going to be available to you. It depending upon yours, you can select and you can watch and you can kind of learn the things. Okay. Now beyond that iconic subscription, one more subscription is there where you are going to get a personal coach who will try to maintain motivation in you, or tempo in you. And if you are a working guy, or if you are not that much self-driven, take iconic subscription. Okay, in which your study planner will be given by them, and study motion sessions will be there, and personalized test analysis, which is actually very crucial, and study materials also they are going to provide. Now coming to payments. In Unacademy, like if you want to take plus subscription for 12 months, after using my code KNR10, you are going to get the course for 27,225. For 18 months, it is going to be 34,650, and for 24 months, it is going to be 39,600. And if you want to go with iconic subscription, okay, iconic subscription for 12 months, it is going to be 40,500, and for 24 months, it is going to be 54,000. Now, at any time soon, they can increase the what is a payment structure, and that too we don't have much time for the gate. Okay, if you want to take the subscription, try to join soon. And every Sunday they'll conduct combat. Okay, and in the combat, means toppers can claim free subscription for 1 year also, and they can claim kind of discounts also, and they will provide free surprise gifts also. Okay, India's largest, obviously, because Unacademy is India's largest now. And you can follow me here at KN Rao for you in Unacademy platform, such that you will get the notifications whenever I come to like live, either in plus or special classes. You are going to get the notification. As per that, you can see me. Now, let us see just outline. I'm not going to take much time here. Okay, outline. Let me tell you about nodal analysis. Basically, in nodal analysis, fundamentally we are depending upon application of KCL, Kirchhoff's current law, meaning that independent variables are going to be voltages. Okay, because if you know at each and every node voltages, then obviously entire system means already you analyze, we can say, because means analysis means that at each and every branch currents we should know, and across each and every branch voltage we should know, power absorbed you should know, power delivered you should know. It can be active power, reactive power, power factor, a lot of things you can find if you know voltages. Okay, for example, if I have resistance like this, okay, and this is V1 and this is V2. Now, if you can find V1 and V2 values, how much is the current flowing through this? Okay, if I think of this as resistance R, now how much is the current flowing through that in that direction is going to be, see here, plus minus voltage. If I know that particular voltage divided by resistance is going to give you the current. So what is this particular voltage with respect to this voltage? I would like to know, meaning that it will be V1 minus V2. So I value is going to be V1 minus V2 by R. Okay, meaning that if you know voltages at each and every nodes, current can be found. If you know voltage and current's power can be found, and that power absorption or delivery can be found. For example, let me have a current source. Okay, let me have a current source like this. Now let me think of this as Vx, this as Vy. You found the voltage Vx and voltage Vy. If you have found, then how much will be the voltage across this is going to be Vx minus Vy. Source current value already you should know. Because it's a current source, right? Now how much is the power delivery by this? Power delivered is going to be Vx minus Vy into source current Is, because current should leave the positive terminal. Such a current direction only we have to take in order to find out the power delivered. You get my point, right? But the problem will come with voltage source. See here, if I have voltage source, okay, this is source voltage Vs. Let me think of this as Vx, this is Vy. Okay. Now, what is Vs? Vs is nothing but Vx minus Vy. Vs equal to Vx minus Vy. Okay. Now, in order to find current flowing through this, what can be done? We cannot do anything, because for a voltage source, voltage is known, but current will be decided by the system connected. So what we are supposed to do now? We cannot do anything. Rather than that, what can be done is, basically this would be connected to one system, right? Okay. In that system, in order to find out the current flowing through this, a voltage source, somewhere here we have to apply KCL. Such that the current entry should be equal to current leaving. Then only current can be found. Then only power delivery or power absorption, whatever it may be, can be found. Okay. Now, application of KCL, if you see. Okay. I have passive element here. I have current source here. I have voltage source here. Independent or dependent, it doesn't matter for us. So here can be found. Here can be found directly. Can be found. Okay. But here it is going to become relation. Because directly KCL, for example, here V1 minus V2 by R is going to be current flowing. Here already current is known, but here current cannot be found. Okay. Now, if you have current sources and if you have resistances or impedances or passive elements, then application of KCL is going to be direct. But here application of KCL is going to be indirect, which is called as supernode. Okay. Now let us see this particular circuit. Okay. Let me have a copy of it. Yes. Now I have taken all current sources first. You see here 1 ohm, 2 ohm, 3 amperes, 4 ix current source, 5 ohm, 6 ohm, 7 amperes current source, and 8 Vx is going to be current source. Direct, no. Application of KCL is going to be direct with current sources. And gradually we will convert each and every source into voltage source, and let us see supernodal analysis. And once supernodal analysis, basically what I am planning to do is, first of all, these are the current sources. Gradually we will convert all these things into voltage sources. And then for that voltage sources, I am going to start with mesh analysis. Gradually I will come back to here in mesh analysis. Okay. So combinedly for mesh and nodal, we are going to consider only one problem, that is sufficient. Then after that, directly we can start solving the maybe whole gate problems or whatever it may be. Okay. Now let us start. See here, which node should be taken as reference node? Yesterday we discussed that a node should be taken as a reference node for which you should get maximum branch connections such that number of terms in one of the equation can be reduced. Yesterday we discussed. So if I think of super node here, only 3 branches are connected. Everywhere 3 branches are connected. Okay. Now if I think of this as a reference node, 4 branch connections are there. So number of terms in one of the KCL equation can be reduced. Let me think of this as reference node. I'm not showing reference node as like this. It should not be said like that. Okay. Now let us think of this as V1. I'm going to write equations only. We are not going to solve equations because such a big problem anyway you will not get in GATE exam. Okay. Now V1, V2, V3, V4. Okay. Now if I think of at V1, current leaving in this direction plus current leaving in this direction plus current leaving in this direction should be 0. Okay. Now current leaving in this direction is nothing but V1 minus V2 by 1. Okay. So current leaving in this direction meaning that plus minus voltage is how much? V1 minus V2 divided by 1. This is 1 ohm resistance. So divided by 1 is going to be current leaving. Now V1 minus V2 by 1 current leaving. Plus what is the current leaving here? Directly it's 4ix. 4ix. Plus current leaving through this is V1 minus V4 by 6. Equal to 0. Now this is controlling variable, right? Basically this is a current controlled current source. Ix is current and this current source is also current. So it is going to be current controlled current source. Okay. Now what is Ix here? Because everything should be written in terms of 4 node voltages. Okay. Such that we need 4 equations. Okay. Now if you apply node at each and every node, you are going to get 4 equations. 4 unknowns will be fine. But Ix is going to be one more unknown. In that case, one more equation is required. So let us convert that Ix into in terms of voltages V1, V2, V3, V4 such that number of equations will be reduced. Okay. Now what is Ix? Ix is here. Okay. What is Ix? V2, this is reference. So with respect to reference, this is at higher voltage of V2. Okay. So voltage across this is going to be V2. Voltage across this is going to be V2. Now V2 divided by 2 is going to be Ix. Is going to be Ix. Right? Right? Now, this is first equation. This is first equation. Okay. Now, let us think of second equation. We have to apply KCL here. Okay. So, current leaving through this plus current leaving through this plus current leaving through this should be 0. So, current leaving is going to be V2 minus V1 by 1. V2 minus V1 by 1 plus current leaving through this is V2 by 2 plus current leaving through this, current source is already known, plus 3 equal to 0. Second equation. Okay. Now let us think of 3. Current leaving through this is how much? Minus 3 amperes. Current leaving through this, V3 by 5. Current leaving through this, plus 8 Vx equal to 0. So this is going to be minus 3 plus V3 by 5 plus 8 Vx equal to 0. Now what is Vx? Basically this is a voltage source but voltage dependent voltage source. Sorry, voltage dependent current source. How much is Vx? Where is Vx? Vx is here. Such that V1 minus V2 equal to Vx. Then we'll be able to convert that Vx in terms of nodal voltages. Okay. Now, what is Vx? Vx equal to V1 minus V2. V1 minus V2. Now, let us try to apply at 4. Now, directly let me write V4 minus V2. Okay. Now, V4 minus V2. V4 minus V1 by 6 plus current leaving 7 plus or minus 8 Vx equal to 0. This is fourth equation. Vx value already we know. Okay. So 4 equations, 4 unknowns. we are supposed to solve. Okay. Now let us take next one. Same problem I have taken. Let me make a copy of it. Now let me convert one of the voltage source, one of the current source into voltage source. Let me think of connecting 7 volts voltage source. 7 volts voltage source. Okay. Now let us try to apply same. All equations will not be changed. Okay. If you think of these equations, the first equation is going to be same, second equation is going to be same, third equation also is going to be same. Because fourth equation only some variation will happen. Okay. But randomly, without having much discussion, let me write. Here we have taken this as V1, V2, V3, V4, and this is reference node. This is reference node. Okay. Now just to get habituation. Okay. Maybe first node or second node I'll write, and after that I'll stop. So that is going to be V1 minus V2 by 1 plus 4ix plus V1 minus V4 by 6 equal to 0. And what is Ix? Ix equal to V2. Ix equal to V2 by 2. First equation. Okay. Similarly, second, third, same equations are going to be there. Right? Same equations are going to be there. Now, if I try to apply KCL here, now current leaving through this plus current leaving through this plus current leaving through this should be 0. Okay. Now current leaving through this is how much? V4 minus V1 divided by 6. Current leaving through this is how much? Minus 8Vx. Okay. And current leaving through this is how much? How much? We don't know. Because it's a voltage source. Now, fundamentally, we need not write this. Because we cannot complete. Now, if you observe, what is our primary concern? Primary concern is nodal voltages should be known. Nodal voltages should be calculated such that if I know V1, V2, V3, V4, remaining complete circuit is going to be solved, I can say. Right? Now, how much is V4? Because this is reference only. With respect to reference, V4 directly connected to the voltage source. So, directly I can write V4. Let me write here. V4 equal to minus 7 volts. With respect to reference, this is drop. Right? With respect to reference, V4 is going to be minus 7 volts. Minus 7 volts. Now, directly I got it. Now, if you see comparison, okay, if you see here in this, we got 4 equations. Those 4 equations has to be solved, meaning that it will give you 4 by 4 matrix. Okay, because 4 variables has to be found. Now, if you see here, though means for example for this voltage source, because of this voltage source, what happened? I need not apply KCL here. Meaning that 3 equations only will come and 3 independent variables only will be there, because directly V4 equal to minus 7. It became easy. See here, in this case, application of KCL is direct. Okay, application of KCL is going to be direct. But complexity of the problem is increased. But if you have means connected one voltage source with respect to reference node, at that particular node, you need not apply KCL at all. Okay, complexity is going to be reduced, meaning that if more voltage sources are there connected with respect to reference node, your problem is going to be simple in nodal analysis. Okay. Now, when voltage source is connected with reference node, with respect to reference node, we need not apply KCL. Complexity is going to be reduced. Okay. Now, let us take the same problem. Let us take the same problem again. In our previous problem, already we convert this into 7 volts. 7 volts. Now, in this present problem, let me convert this into 3 volts. Okay, I added one more voltage source. In which super node will come. Okay, let me take a copy of it for next reference. Best. Okay, now let us try to write equations. Okay, here anyway, see, let me write here V1, V2, V3, V4. Focus on this problem because after getting equations only, I am going to use the term supernode. Directly, I am not going to use anything. Okay, because directly if I say supernode, saying like this node and this node is same, let us combine. One problem will be there. That is actually students. Even I used to do that mistake when I was there in meeting. Okay, so see here, I used to solve the problem in this way. By like Hythen Kimberley I followed at the time. See here, this node and this node combinedly is a one node supernode, people say. Then how I used to write the equations is, okay, V2 minus V1 by Vx, leaving current, plus V2, this, and this voltage, this particular node and this particular node is same only, no. So I used to use V2 by 5 here. No, it will be V3 only. Okay, so in order to avoid that mistake, I would like to take the equations. From the equations, I'll come back it as supernode such that particular in your subconscious mind it will be stored. Okay. Now see here. Let me write first equation. This equation leaving is going to be V1 minus V2 by 1 plus 4ix plus V1 minus V4 by 6 equal to 0. First equation. What is Ix here? Ix is going to be V2 by 2. Problem solved. Now let me apply KCL to the second bus or second node. Okay, second node. Leaving currents plus leaving currents plus leaving currents. Okay, what is the leaving current there? V2 minus V1 by 1 plus leaving current is V2 by 2, because here also I have taken this as reference node. That's default. Now, how much is the leaving current from here? We don't know, it's a voltage source. Let me think of this as IP. Some current. Okay. But I know that whatever be the current leaving through this, the same current is supposed to enter here. Same IP has to enter. Okay. Now, see, leaving current through this I considered, leaving current through this means I added one more variable, that is IP. Equal to 0. This is second node. Okay. Now let us think of third node. At third node, leaving current through this plus leaving current through this plus leaving current through this equal to 0. Leaving current through this is minus IP. Leaving current through this is plus V3 by 5. Leaving current through this is 8Vx. This is node at third. Now what is Vx? Already we know V1 minus V2. Now I can eliminate IP. Means by combining 2 and 3. Now let me combine 2 and 3 and let me form only one equation. Okay. Let me use black. See here, if I send it to the other side, IP value is going to be this much only. Okay, IP value is going to be this much only. So if I write the equation here, V2 minus V1 by 1 plus V2 by 2 plus V3 by 5 plus 8Vx equal to 0. IP got eliminated or not? Yes, IP got eliminated. Now this is going to be first equation, I got it. 2 and 3 combinedly, one equation I got it. One equation I got it. Okay. Now let us think of 1 is over, 2, 3 combinedly we got one equation. 4 I need not apply any equation. V4 equal to minus 7 volts. Already we know. Already we know. Okay. Now from here, by this equation means how like in the circuit how it is being represented. Let us see. Okay. For this, let me use some other color, black, red, blue. Let me use red. Okay. First of all, V2 minus V1 by 1. V2 minus V1 by 1 is current flowing through here. V2 minus V1 by 1 plus V2 by 2, current flowing through this, plus V3 by 5. V3 by 5, current here, plus 8Vx, current here, equal to 0. Okay. See, logic is very simple. If current leaving through this, plus current leaving through this, plus current leaving through this, but current leaving through this I don't know, but I know that same entering current will be there here. Same entering current will be there here. Here entering current equal to 2 leaving currents. That's it. Okay, relax. See, leaving current plus leaving current plus leaving current. But I don't know the value of this leaving current. But I know the same value of leaving current will enter here. This entering current equal to 2 leaving currents. Problem solved. And here we call this as super node. Because here I applied KCL, combinedly you are going to get one equation. So from now onwards directly we can apply in this way. Okay, but anyway, I don't give the concept of leaving current, which is nothing but entering current and all, because in the next phase, we are going to consider this also as a voltage source. Then it will be much beneficial. Okay, just wait. Now this is the way of equation. Now see, better. Okay, see, this is going to be first equation. Combinedly, I got the second equation, and this is going to be third. Okay, where is going to be fourth, because we need 4 equations, right? Now, V2 minus V3 is going to be 3. Is going to be 4th equation. Now, previous means if I compare with previous one, see here. Okay, if you see here, how many nodes we got? 5 nodes. Out of 5 nodes, 1 node went in as a reference node. So 4 times you applied KCL. 4 times you applied KCL because only current sources are there without having any voltage sources. 4 times you applied KCL. Now, see here. If you see here, means again 5 nodes are there. 1 node will go as a reference node. 4 KCL equations need not be written because out of 4 equations, 3 equations you have to do by applying KCL. 4th equation is going to be relation. You need not apply KCL. Directly you are going to get. Okay. So the moment you have one voltage source, one equation got reduced. The moment you have one voltage source, one equation got reduced. Okay. Out of 5 nodes, 1 will go as a reference node. Out of 4 nodes, 1 voltage source is there. So 3 times KCL, 1 time is going to be relation. Just by saying that, we will be able to find. Okay. Now, take this. In this, what happened? Means again, 5 nodes are there. Okay. Out of 5 nodes, 1 node go as a reference node. Out of 4 equations required, 2 voltage sources are there. two voltage sources are there. So two are going to be relations. Is it fine? Okay, fine. Now, out of 5 nodes, one node is going to be reference node. So 4 equations are required. Out of 4 equations, now 3 are voltage sources. So only one time you are supposed to apply KCL, and the remaining 3 should be relations. First of all, let us think of relations. Okay. As usual, let me write V1, V2, V3, V4. V1, V2, V3, V4. Okay. And this is going to be reference node. Okay. Now, in this, only one time KCL should be done. 3 times relation should be done. So, let us start writing relations. V2 minus V3. V2 minus V3 equal to 3. One relation. Easy. See, means now problem is becoming easy. Now, if you think of V3, V4. Okay. V3 minus V4 equal to 8Vx. Second relation. Okay. Now, what is Vx? Vx is nothing but V1 minus V2. V1 minus V2. Okay. Now, where is the third relation? Third relation is going to be V4 equal to minus 7 is going to be third relation. Okay. Now, whatever I said, like without kind of super node and all, directly let us apply KCL only. Leaving current should be entering currents and all, that will be sufficient. Now, let us start KCL. Okay. If I start KCL here. Okay. Now, what is the leaving current here? V1 minus V2 by 1 plus 4Vx, 4Ix plus V1 minus V4. V1 minus V4 by 6 is going to be fourth equation equal to 0 is going to be fourth equation. Okay. So, one time you are supposed to apply KCL, remaining 3 directly relations only you are going to get it. Now, one thing here is, for example, if you try to, because this is the boundary, okay, if you try to apply KCL at the second node, what is going to happen? Let us see. You are not supposed to apply. Okay. If you try to apply at the second node, let me use red color. Okay, blue color. Fine. Okay. If I try to apply KCL here, what is going to happen? Let us see. Leaving current through this plus leaving current through this plus leaving current through this. Okay. Now, see, leaving current through this is V2 minus V1 by 1 plus leaving current through this V2 by 2 plus leaving current through this. I don't know. That leaving current is going to be entering current. This entering current is equal to 2 leaving currents. Okay. See here, this is the leaving current. See, this leaving current plus this leaving current plus this leaving current should be 0. Now, this leaving current is nothing but this entering current. Now, this entering current is nothing but 2 leaving currents. Okay. So, this plus this plus this plus this. This meaning that this is nothing but this plus this. How much is this current? V3 plus 5. V3 plus 5. After that, V3 plus 5. After that, plus this current. How much is this current? I don't know, because it's a voltage source. How much is this current? This current is nothing but this current. You understood, right? So, see here, this plus this plus this. This I don't know. This. Meaning that this equal to this and this. Entering current equal to leaving currents. This I know, but this I don't know. Meaning that this is nothing but this. And this entering current equal to 2 leaving current. Now, how much is the leaving current of this? How much is the leaving current of that? Is going to be plus V4 by 6. V4 minus V1 by 6 is going to be the leaving current through this. Again, how much is the leaving current through this? We don't know, right? Relax. This plus this should be 0. And this I got equation, this I couldn't get equation. Now, this leaving current is nothing but this entering current. Okay, this entering current is nothing but these 2 leaving currents. This current I know, but this current I don't know. But this leaving current is nothing but this entering current. Okay, but this entering current is nothing but two leaving currents. This current I know, but again I don't know this current. Okay, now see, relax. This leaving current is nothing but this entering current. This entering current. This entering current is nothing but these four leaving currents. These three leaving currents. Okay, now relax. See, this leaving current is minus 4ix. This leaving current is minus V2 by 2. But this leaving current, we don't know. This leaving current is nothing but this entering current. This entering current is nothing but these two. So it will go on, it will go on, it will go on. You cannot write the equation. So one thing I'll tell you, keep 2 stars. At any cost, by applying KCL, you are not supposed to apply KCL at reference node. Okay, see, this plus this equal to 0. This I don't know. This is nothing but this. This equal to this plus this. Okay, this I know, this I don't know. This is nothing but this. This is nothing but this plus this. Okay, this I know, this I don't know. So in order to find out this, I am touching reference node. If I touch reference node and if I apply KCL at reference node, you cannot calculate. So see, we should never ever try this. Okay, see, 5 nodes, 1 reference node, 4 nodal equations, Out of 4 nodal equations, 3 voltage sources, 3 relations. Only one time you are supposed to apply KCL. Means here only you are supposed to apply KCL. If you directly try to apply here, you will be in a big mess. Okay, so while applying supernodal analysis, at any cost, you should not touch your reference node. Or because reference node meaning that we are not supposed to apply KCL at the reference node, right? So out of whatever it may be, if you touch a reference node and if you try to apply KCL at reference node, it will be big mess. Okay. Now, just a minute. Sorry guys, actually I forgot to copy this. Just a minute. Sorry guys, I forgot to take a copy of it. Okay, now I'll take a copy. Now, see here, let me convert this into 7 ohms resistance. Let me convert this into 7 ohms resistance. Now let me have a copy of it. Now, again, how many nodes are there? 5. Reference node. How many voltage sources are there? 2. So 2 times KCL, 2 times relations we are supposed to apply. Okay. Now let me write directly relations first. This is V1, V2, V3, V4. V1, V2, V3, V4. Okay. Now let us write equation at 1. Okay, 2 times KCL, 2 times relation. Okay, let me write relation first. V2 minus V3 equal to 3. First relation. Okay, and V3 minus V4 equal to 8Vx. This is second relation. And what is Vx? Vx is nothing but V1 minus V2. Got it, right? Now, let us see what else can be done. Okay, means we are supposed to apply KCL 2 times. Now, let us apply at first node. Let me write V1 means leaving current. So, this is going to be V1 minus V2 by 1 plus 4Ix plus V1 minus V4 by 6. equal to 0. Third equation or first KCL equation. Now let us try to apply it V2. You have to focus here, buddies. V2. Okay, relax. See here, this leaving current plus this leaving current plus this leaving current equal to 0. But as it is a voltage source, this leaving current I don't know, but I know that this leaving current is nothing but this entering current. Okay, now this entering current should be equal to two leaving currents. Now this leaving current I know, but this leaving current I don't know. But this leaving current is nothing but this entering current. So this entering current is nothing but these two leaving currents. Okay, meaning that, see, this current plus this current plus this current should be 0. Now this I know, this I know, this I don't know. But I know that this is nothing but this. Now this current is nothing but this plus this. This I know, again this I don't know because it's a voltage source. Now this current is nothing but this current I know. Now this current is nothing but this current plus this current is going to be the answer. Okay, so this is going to be this current plus this current. This current I don't know, but this current is nothing but this current. This current is nothing but this 3. And this current I don't know. This current is nothing but this current. Okay, this current equal to two leaving currents 3, 4, 5. Meaning that indirectly from here to here, it is becoming a supernode. Okay, now let us start. First is going to be V2 minus V1 by 1 plus V2 by 2. This current, this plus this. This is how much? Plus V3 by 5 plus this current. This current I don't know, but I know this current. This equal to this. This is nothing but 4 and 5. 4 is nothing but V4 by 7 plus V4 minus V1 by 6. This is for the equation. You understood now, right? See, 5 nodes, equations, relations, KCL. Now, if you're what they say, analyze, if you have more voltage sources, nodal would be better because in the easiest way you will be able to complete. Now, if you have current sources, application of KCL is going to be direct. But if you have voltage sources, completing the question will be easy. It is sooner you are going to calculate. Okay. Now let us think of this again. Let me have a copy of this. Because for mesh analysis, I am going to consider this as the first problem. Seven volts. Now what else? Let me convert this into a voltage source. 4ix. Maybe plus minus. Now 5 nodes, equations. Okay. Now 4 voltage sources are there, meaning that you are not supposed to apply KCL at all. Without applying KCL, V1, V2, V3, V4. Okay. Now what is V1 directly? Means we are not supposed to apply any KCL equations at all. All equations has to be written by relations. V1 equal to 4ix. How much is ix? Equal to V2 by 2. Okay, one relation. And V2 minus V3 equal to 3. Second relation. V3 minus V4 equal to 8Vx. Third relation. And what is Vx? Is going to be V1 minus V2. Now, what is fourth equation? V4 is going to be minus 7. So, means if you have more and more voltage sources, okay, if you can form more and more supernodes, or if you have more and more voltage sources, application of nodal is better. Though it is not direct, in a fastest way, we will be able to get the solution. Okay, simple. 5 nodes here, 4 equations, 4 voltage sources. So I need not apply KCL at all, right? For this problem, for this means before entering into mesh. Okay, so for this problem, if you are trying to apply mesh analysis, voltage rises equal to voltage drops. Mesh analysis, voltage rises equal to voltage drops. Mesh analysis. If you try to apply mesh analysis for this, 4 equations will come. Okay, 4 equations, because everywhere voltage sources are only, mesh analysis meaning that KVL. Okay, meaning that currents are going to be independent variables. I can say that this as I1, this as I2, this as I3, this as I4, this as I4. Okay, now means everywhere you will be able to write the equation. See here, everywhere you will be able to write the equation. Everywhere you will be able to write the equations directly, but 4 equations of this much length will come, will not be able to solve soon. Okay, now for this problem, that's why this problem I am going to consider as the first problem, for mesh analysis, and again I will go back such that, okay, ultimate conclusion will be like this. For this problem, application of KCL or Nodal would be better. Mesh we should not go. Okay, and our conclusion will be, for this problem, okay, mesh analysis would be better. For this problem, see, 4 current sources I have taken, no? Means for this problem, if you go to Nodal, 4 big equations will come. But if you go with mesh, with relations, you will be able to solve. Okay, so in the next session, we will see remaining part. But for mesh analysis, I am going to consider this problem as the reference problem, and step by step, we will go back. Okay, thank you guys, and very all the best. Try to